He is a fan of lawnmowers. He is a sales engineer at Snowflake, and he is a fantastic expert in the field of data science in general. Please welcome Graham.
Hey, thanks, Jesse. Today, the first presentation today is all about my opinions, okay? So this is going to be very opinionated. There's going to be no science involved. I've been working in the field of analytical databases for a number of years. I'm going to tell you what that is to start with, and then I'm going to talk about how you don't produce a solution to meet that problem. An analytical database is one that's designed to answer these kind of questions. So how is your company doing? How can you do it better? And getting an insight into your customers. Who are your customers? How can you get more customers? And how can you keep your existing customers happy? Behind the scenes, the technical side of things, it's mostly about querying with SQL. It's rarely about just one record. What we're doing here is talking about calculating statistical functions over a large amount of values. So the average, the maximum, the standard deviation, who's the best salesman in this region in this period, that kind of idea. And the amount of data over my lifetime has stepped up from gigabytes to terabytes, and these days petabytes isn't something that makes the news anymore. This is me with my lawnmower. Just to go off topic for a little while. I love this lawnmower. It's a machine that is made for a particular purpose. It's fantastic. I've cut with very bad, cheap lawnmowers in the past, but I decided to spend a lot of money on getting myself a new lawnmower. And I won't tell you how much it cost, but it was a fair amount of money. And the thing is about this lawnmower, I only use it about 10, maybe 12 times a year. And the rest of the time it's sitting in my garage and not doing anything. So I started thinking, I've got this incredible asset that cost me a lot of money. Is there anything else I can do with it? So I got a bit creative. I thought, can I cut my hedge with this lawnmower? Turns out I can't. If I ever got that lawnmower started, I'd probably cut my fingers off. It's not the right thing to do with my lawnmower. And making applesauce with the lawnmower, that was not a great experience. You can imagine the shape of the applesauce, not very tasty when you'd taken it all together. This was the point where my wife ran out and stopped me experimenting. If I start cutting the hair of my children and my pets with my lawnmower, then that's quite dangerous. So the point here is that a lawnmower my particular lawnmower is incredible for cutting the grass. Not very good for anything else. The fact that it's expensive isn't an excuse for me to go and do other things with this lawnmower. Let's get back on topic. Let's talk about Hadoop. Hadoop, to me, is like the lawnmower. It's an incredible technology. It was invented to basically index the internet, which was a task that was impossible before the invention of Hadoop. Unfortunately, just about everything else, every other challenge in computing is not like indexing the internet. And in particular, my first love of analytical databases involving SQL is one of those things that Hadoop isn't particularly good at. I have some experience with products that have a layer of SQL over the top of Hadoop, and they are really not performant. And everybody pretty much agreed, and they decided, hey, let's change Hadoop. I mean, Hadoop is MapReduce plus HDFS, or it was originally. So the options are maybe let's start with Hadoop and make some changes so that it is good at doing SQL analytical processing. So either change the MapReduce or change the HDFS. using products like Spark, for example. In my opinion, this is the kind of setup you get. You get something that is not particularly good at either technology. By bolting something on to an existing technology to make it do something completely different, you don't get the right kind of result. In fact, both of these lawnmowers have probably been ruined as lawnmowers as a result of being turned into a digger or turned into a bicycle. In fact, the one on the right, I think, could actually work. I would maybe buy one of those in a particular mood. Merv Adrian from Gartner kind of agrees with me. It is remarkable that Hadoop can support SQL. It's just don't expect it to do very well because that's not what it was built for. That's not its original purpose. So, how do you build an analytical database if you can't start with Hadoop and build stuff onto it? You could start with one of the other multi-purpose databases that have been going for around 40 years. So, Postgres, SQL Server, Oracle. They can, to a certain extent, do some of this analytical processing. But as the data volumes increase and the complexity of the algorithms that you're running increase, these things just don't scale. You need something that's been built specifically for that particular workload, that particular job. Again, they hit the kind of position with Hadoop where they decided, why don't we add some stuff to it? Why don't we, in my words, pimp my multi-purpose database? Let's take the basic shell of a database and add some stuff onto it. So during the early years of this century, there were a number of projects that actually did pretty well. They started with a database like Postgres and then started adding stuff onto it. So Netezza was one of the most profitable in this group. They took the Postgres open source database and they added a parallel component to it so that you could run lots of jobs in parallel. Greenplum and Parexel were also in this field. They added a technology called column store or columnar storage, which is particularly useful for the kind of analytical SQL jobs that I specialize in. And then there is Redshift, which is one of the from Amazon, which is actually an adaptation of the Parexel database, except taken into the cloud. So it's at its core, it is Postgres with some parallel, with some columnar, and taken up into the cloud. I've got my opinion on those kind of databases as well. I think the same kind of problem. If you take something that was built for one purpose and add some stuff onto it, you don't necessarily get the right kind of result you would get if you built it for scratch for this particular purpose. There is one other database that's worth mentioning. I'll blot out any of the references to it. I don't want to mention them by name. However, this is 12C of their product. The thing with this product is that it's been going for over 40 years, and every release, new stuff is added onto it to cope with different challenges. Recently, they produced an in-memory analytics engine to make it more suitable for analytical processing. I find that over time, this thing has built into a level of complexity that is almost impossible to comprehend. This architecture diagram actually has a comment at the bottom that says, please print on A3 paper. I think if your architecture diagram doesn't fit onto a side of A4, then there is an issue. I'm actually a huge fan of this technology. I used to be a qualified DBA using this particular technology. But even so, I think that over time, this technology has come to this kind of position where it has so many add-ons and extras and crazy features that nobody really understands, that it's almost become difficult to use for its primary purpose. So in the field of analytical databases, I'd say that the right approach is not to make applesauce with the lawnmower. I'm going to have a T-shirt printed with exactly that slogan. What you shouldn't use something that is good for one thing for doing something else just because it's expensive and you want to get value from it. I described this other technology as Frankenstein's monster, kind of adding on bits to an existing technology to make it do new things. I don't think that's the right approach. I think you need to build something from the ground up for a particular purpose. In this case, analytical SQL. And, excuse me, how do I go back? And yeah, there are solutions that were designed for quite a different world that have tried to keep pace with the issues we have in 2017 with the volume of data and the complexity of the algorithms that need to run against it. What you don't need is something that's been patched over time to take account of these new features. What you need is something that's been built from scratch to meet those features. And in particular in the cloud, which is my particular area of interest, there are products built specifically to take advantage of the basic physics and economics that cloud computing bring in terms of cheap computing, in terms of ability to scale. And I'm going to talk about these in the second part of this talk. We're going to have a more practical session with my colleague from Talent, and we're going to actually show you how Snowflake, which is the database company that I work for, have a cloud database that has been built from scratch, not based on anything else. And we'll talk about how that can be used. I think actually at this point I'm ahead of time. I talk really fast. Has anybody got any questions right now? I mean, I think I'll take a couple of questions if anybody's got one. If not, I'm going to move on to the next talk. Fantastic. This is so light.